matrices method to solve a simultaneous equation. Basically, it's not just the matrices method, we're going to use the inverse method. Alright? So here's the simultaneous equation. So we have 3x plus 2y equals 7. We have negative 4x plus y equal negative 2. First thing, we want to write it in the matrix method here. We want to write this in the matrix method, and 2, then we're going to use that to solve the simultaneous equation. Alright, so firstly, the matrix method. In the matrix method, we are just going to focus on the coefficients of the variables, and we're going to put them in a 2 by 2 matrix. For example, 3, 2, negative 4, 1. Alright, so there we have it, 3, a 2, negative 4, 1. So that would have been for the 3 here, the 2, the negative 4, the 1. We have x, y. The reason why I have x at the top is because the first column is x and the second column is y. So the first column goes at the top, the second column goes there. And this is equal to 7, negative 2. That's that. So this is the matrix format. So how do we use this to solve the simultaneous equation? First, we need to find the inverse of this. We need to find the inverse of this, which is the 3, the 2, the negative 4, the 1. So the inverse of this, let us say we call this matrix. Let's call this matrix A. All right, for labeling sake. So the inverse of A. How do we find the inverse of A? Well, the inverse of A can be found by using 1 over the determinant of A, and we multiply that by the adjoint of A. Alright, so we can do this one time, or we could do it part by part, but let's say we're doing it one time. 1 over the determinant of A. The determinant of A is going to be the product of the main diagonal, which is 3 times 1, minus the product of the minor diagonal, or the other diagonal, which is negative 4, 2. So this is going to help us to find the determinant. And then now the adjoint is simply switching the elements of the main diagonal. So I have a 1 and a 3. And then I change the signs of these. So this is a positive 2, 4, and a negative 2. So when I finish exercising this, or executing this, what I have is the inverse. So this is actually 1 over 3 plus 8, that's 11. And then we have 1, negative 2, 4, 3. Basically, this is the inverse. But to get it down further, we're just going to multiply this by everyone. So we get 1, 11, negative 2, 11, 4, 11, and 3, 11. So there it is. This is now our inverse for this. Based on the principle, what we had discussed, earlier, based on the principle, what we had discussed earlier, have here. We're saying that if you have a matrix times another matrix equal to another matrix, to find this matrix here, all you have to do is to find the inverse of this. And this must be a square matrix for you to take the inverse. So if you can find the inverse of this matrix and use it against itself right here, this part will give us what is called the identity matrix, right? And then if we have the identity matrix, this one will give the identity matrix. So the identity matrix multiplied by anything will actually leave back the thing. So basically to find this, all we have to do is to get the inverse, and then we're going to have to put the inverse of A over here. So basically what we're going to do now is just to have our X and our Y here. Inverse is 1, 11, negative 2, 11, 4, 11, 3, 11. What we're going to do is simply to put it right here, and then we're going to carry out our multiplication, and then we should get our answer. All right, let's see what we have. Where could I write it? I think I could write it down. So we're looking at 111 times 7 plus negative 211 times negative 2. I'm seeing that as a 1 though. When we're done, it looks like a 1 already. And then for this part, we're looking at 411 times 7 plus 311 times negative 2. And I'm seeing a 22, so let's go. So when I look at this, this is actually 7 plus 4 over 11, which is 11 over 11, because we're looking at 11 over 11 for that part. And then this part, this is 28, and then minus 6, so that is 22 over 11. And then, as you could see, finally, x over y is equal to 1 and 2. So basically now we could conclude that, all right, x is equal to 1 and y is equal to 2. So that's using the matrix method. That's using the matrix method to solve the simultaneous equation. All right, using the matrix method. So there are our answers.
I can't do it right now.
Those are our answers.